Hello again. Thanks for joining us. This is Space Nuts, where we talk astronomy and space science. My name is Andrew Dunkley. Coming up, we are going to look at Starliner yet again. Gee, it's getting a Guernsey in just about every episode of late, but, well, there's been plenty to talk about, let's face it. Also, another spacecraft, which is the product of SpaceX, looks like it's going to be doing missions to Mars in the not-too-distant future. What's that all about? Well, it's one of those great dreams of a great man, and we'll see what he's got in mind. There's also suggestions that our galaxies are bigger than we thought, much, much bigger. Why? How? What's it all mean? And a passing star might have been causing a little bit of disruption out around that trans-Neptunian area. We'll talk about all of that on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And here to discombobulate all of that and to brush off brush turkeys is Professor Fred Watson, astronomer at large. Hello, Fred.
Hello, Andrew. Yes, you've just touched on the nerve that's affecting us all at the moment in brush turkey egg-laying season. They want to be everywhere.
So you've got them scratching around your backyard, literally.
Literally, yes. They dig up everything to try and build a nest, and it's they're a protected species. They're probably endangered, actually. So we're very fond of brush turkeys, but what they do to your garden is pretty serious stuff. So we just try and... I've actually tried contacting their solicitor and things of that sort just to see whether that has any effect, but we'll see.
Yes. They're damn ugly, though, Fred. I mean, they're endangered and they're protected and then Australian natives, but they look like a cross between a traditional turkey and a vulture.
Yes, yeah, that's actually a really good description. They do, and they've got the brain of an ant as well. So they're not sort of they're not gifted in. I mean, when you compare them with some of the other species that we have around here, particularly the sulphur-crested cockatoos, which have got the intelligence of a primate, the intelligence of
they're very bright,
extraordinary creatures. We've sent a note to them as well about leaving their droppings on our outdoor furniture, but that's still a matter for the legal fraternity.
Well, I'd be surprised if they haven't destroyed your furniture. No, they love chewing things.
They do like chewing things, yeah, but they've been okay so far. I think yeah. So far, so
I love sulphur-crested cockatoos. Yeah. We've got squillions of them out at the golf course, but they're not loved when you're just in the middle of your downswing and one of them goes.
Oh yeah, they
go. What was that?
If you're standing next to one, they'll nearly drive your eardrums out there.
Oh, yeah, they're loud. They are super loud. Okay.
Anyway,
what wildlife issues aside, let's talk about Starliner for a change. Some good news at last.
Yeah. So Starliner, the spacecraft that we've been talking about solidly for the last 2.5 months, 3 months actually.
Yes,
has made a textbook return to Earth at the end of last week. Disconnected from the International Space Station. All 27 of its thrusters worked perfectly because that was the big ticket item, whether the thrusters were reliable or not. Backed away from the spacecraft, fired its rockets to re-enter and touch down completely safely, exactly on target, in a huge vindication, as some of the media are reporting it, a huge vindication for Boeing's engineers. And I think there's been a lot of backpatting all around, which is great, including the 2 astronauts left behind on the space stations,
yes.
Williams and
I feel terrible for them.
They were full of congratulations to the Boeing engineers who they've worked with very closely, obviously for a long period of time, not just while they've been in space. And they reconciled themselves to another however many months it is in space quite some time ago, and so they had already made peace with the whole issue, and they're full of congratulations. As are NASA too. We had reports of a bit of friction between Boeing and NASA about this, and certainly there was some robust discussion, we believe, in meetings, but nothing like what might be blown out by the tabloid media. And so, I think there's congratulations all round.
Yes, it is good news, and of course the 2 Starliner astronauts are still on the ISS and will be there probably till early next year. And by the time this podcast is released, Starliner would have been on the ground for probably nearly a couple of weeks. But it's worth mentioning that they brought it back safely. All is well. It just didn't have any passengers. It was just auto-piloted back to Earth, which is extraordinary in itself, the way they do that these days with all these different spacecraft. They don't need humans to make them go up and down, but they do need humans to push the magic buttons that are just there for decoration, I think. But seriously though, it's good to have it back. There must be a collective sigh of relief. Okay. Yes, let's move on to another spacecraft, and this one is the brainchild of SpaceX, the Starship mega rocket, which they say in the next couple of years will be sending missions to Mars, initially unpersoned, but ultimately leading to people going to Mars. This is actually a plan that might. We talked about before, and people are saying, "Oh, it's a pipe dream; it'll never happen." But they're certainly looking seriously at Elon Musk's plan of putting a city on Mars. He's still going there.
Yes, so that's right. That's the whole motivation for developing Starship, Andrew, and it's quite remarkable. It is remarkable hardware. So it's two parts to it. The first stage booster, which is called the Super Heavy, and then the upper stage, which itself is 50 meters tall, and that's the second stage, known as Starship. And unlike most spacecraft, and certainly the Falcon 9 series that Elon has developed, which has a first stage and then a separate second stage and then the payload itself, with Starship, the payload is built into the second stage. And so it is really quite a different sort of architecture for the spacecraft from others. So what we have is a tweet from, I beg your pardon, a SpaceX, sorry, an X, whatever it's called, message, formerly known as a tweet from Elon Musk on Saturday, last week as we are speaking. A post, that's the word I want, a post on it. Yeah, and so what he's saying is what his target timelines are for the first Starship missions to Mars, and it is 2 years. That is exactly as you've said, uncrewed missions to start with trials to land on Mars. And he's talking about that happening in 2 years. And then 2 years later, and he's partly limited by the physics of getting to Mars, which you can only do every 26 months. That's when the orbits of the two planets bring them into the right kind of alignment, so that when you get to the other end of the trip, Mars is where you want it to be rather than somewhere else in its orbit. So that happens every 26 months. So 2 years' time, an uncrewed mission to Mars, or perhaps several, and then in 4 years' time, he's talking about sending people to Mars. And his quote is, "Flight rate will grow exponentially from there, with the goal of building a self-sustaining city in about 20 years. Being multiplanetary will vastly increase the probable lifespan of consciousness, as we will no longer have all our eggs literally and metaphorically," actually says metabolically, on one planet. So got them both. Look, it's Elon Musk at his finest in terms of big vision stuff. I think the rest of the world is looking on and saying, in your dreams, because there's so many unknowns about getting humans to Mars. It's something that we are simply faced with, real difficulties that brute force and ignorance is just not going to cut it. So I think we'll see slippage perhaps from that. But what's interesting to us as space watchers, of course, is seeing that technology evolve. Just a final footnote about this, Andrew. The Starship has had 4 flights so far, and the last one basically achieved all that was hoped to achieve. And the 5th one is being planned. And I think the 5th one is the crucial one, because they will return the spacecraft, the Starship, back to Earth on a soft landing, rather than just losing it into the ocean, which is what's happened before.
Yeah. Look, people might be laughing behind his back and saying this is just a pipe dream, but if you don't have people that dream big, you probably don't achieve things at the high end of the spectrum. I'm sure, because you don't hear about it in the history books, but I'm sure people laughed at the Wright brothers and everyone else who was attempting to fly back in those days.
Yeah, that's right.
They probably thought it was a huge joke. You'll never do it. It's impossible.
Yeah.
Well, now look at us.
Yeah, and 10 years ago, 10 years ago, it was thought to be impossible to reuse a booster, your first stage rocket, and that is now totally routine. It was 2015, I think, the first successful booster landing. And you've only got to look at the track record with Tesla vehicles as well. This dreaming big can achieve great things.
Yeah, notwithstanding the one Tesla vehicle that's floating out there in space somewhere.
Yeah, the one that was on its way to Mars but actually overshot and is now in the asteroid belt, I think. So that's it's a salutary lesson there.
Yes. It's probably looking for a parking space station. Boom, boom.
One with a charger on it.
One with a charger. Yes, that could be an issue. But look, I think Elon Musk is a remarkable man. I know he gets ridiculed and he cops a lot of flack, but he has done some incredible things in the space science world that probably wouldn't have been attempted this soon by many other people. I know that he's not the only one, but he's getting all the headlines, and he certainly knows how to get the story out there and get the interest of the public. I don't doubt that he will ultimately achieve this.
Yeah, I agree.
Maybe not this quickly, but how quickly has he perfected these rockets?
But what Andrew? What if he did? What if in 4 years' time we're talking about people walking on Mars?
Yes.
With a Starship parked in the background. It's not impossible.
No, it would be remarkable,
but it's not.
It would probably be the achievement of the century, because it would be 20 years ahead of when NASA plans to be there, at least 10 years ahead, and it would be a private venture. That would be even more remarkable.
Yeah.
Yeah, I wish him well, and I hope we get to see it. I think it would be fantastic, and yes, I wish him nothing but success. I'm sure most people do, and you've got to also think about the brave people that will be doing this, because it's not like crossing the Atlantic for the first time, or crossing Bass Strait for the first time, or any of those kinds of ventures that we heard about 100 years ago, but it's a giant leap, a gianter leap than the moon, and that was a huge jump. So it's all very exciting.
Maybe I can go ahead, Andrew. Sorry.
Yeah, it will also reinvigorate interest in space science. So it'll breed a whole new generation of scientists, and then it will just keep going. I think.
The point where I think many space watchers and astronomers and philosophers, perhaps I can put it, ethicists, where they diverge from Elon is his sentence: the flight rate will grow exponentially from there, with the goal of building a self-sustaining city in about 20 years. That, I think, transgresses the way we ought to think about the way we treat Mars, and it's part of Elon's philosophy of believing the Earth is doomed and that we need to, have a lifeboat. Mars is not our lifeboat, and what we have to do is fix our planet. And if you want to have a lifeboat, build it. You build a mega structure rather than going and trashing another planet. That's my on all this.
No, I know you've got issue with occupying other worlds, but the time will come where more powerful people will probably end up making those kinds of decisions. Yeah, it sounds like Elon's made his decision.
Oh, he has. Yes, that's right.
And mining on the moon.
Yeah,
whether you like it or not, that's probably going to happen too.
Yeah, and that's, I think, a different issue. I think you can argue for that from an ethical point of view. I'm not sure about colonizing Mars, though. Look, I've no problem with humans going to Mars, but the model I think we should adopt is a bit like Antarctica, where it's scientific and research purposes mainly, rather than
but nobody can wholly own it or occupy it. Yeah, that's fair point. Okay, yes, very interesting story. And if you want to read up on that, it's on the space.com website. This is Space Nuts with Andrew Dunkley and Professor Fred Watson.
Roger, you're loud and clear here also.
Space Nuts.
Now, Fred, we have talked quite a few times and received a lot of questions about the impending merger of the Andromeda and Milky Way galaxies. But now there's a story that suggests they are already touching each other due to this discovery that the galaxies are bigger than we thought. How so?
And this is a great story because it's got a very strong Australian connection. Scientists from Swinburne University down there in Melbourne. And it's interesting from a number of points of view. One is that Swinburne University has a deal with the Keck Observatory in Hawaii. The two Keck telescopes, they're both 10-meter telescopes, are on Mauna Kea, the tallest mountain. It's not really a mountain, it's a shield volcano, but it's still one of the highest points on the planet Earth on the big island of Hawaii, Mauna Kea. So the Keck telescope is a 10-meter telescope that has very, very fine sensitivity. It can penetrate deep into space, not just looking at very distant objects, but looking at fainter things in the near field, things that are around our own galaxy, so other galaxies in the what you might call the middle distance. So what this team has done is they've sort of invested time on one of the two Keck telescopes, and looked at the gas that surrounds galaxies, and in particular a galaxy which rejoices in the name of IRAS 08339 plus 6517. That's one of the galaxies that they've looked at, and what they've done is checked for glowing gas around the galaxy. So, we when we look at galaxies, look at pictures of galaxies, which many of us do all the time. What we're looking at mostly is the stars, and often glowing gas as well. The pink blobs in the spiral arms of galaxies are pink clouds of glowing hydrogen. The old joke is that hydrogen is just like people. When it gets excited, it glows pink, but the mechanism's different. So they've instead looked at glowing oxygen and looked at it at very, very great distances from the centers of these galaxies. And basically, they find it goes much, much further than anybody had expected. And this is a real achievement because this gas is 10,000 to 100,000 times fainter than the brighter parts of a galaxy. So, that's just penetrating really deep into the fainter regions of the universe. And so, so what they've discovered is that that perhaps each galaxy has this shroud of gas that extends maybe 100,000 light years into space. Now, 100,000 light years is what we usually think of as the diameter of the disk of our galaxy. So, if you basically double that in size, you've got the new version of what galaxies are like, how big they are, and they are colossal.
And is it true that because of this, they believe that Andromeda and our galaxy are already touching, technically speaking?
Yeah, yes, that's right. I mean, this Andromeda galaxy is about 2.5 million light years away from ours. If you've got 100,000 light years of gas, worth of gas in each of those galaxies, they're not actually touching, but they may well be interacting at the extremities because gravity operates over great distances. So they may be already tugging at one another, if I can put it that way, with these halos of gas. So yeah, I think it's a fair point to say that collision with Andromeda has already started. Hold on to your hats, everyone.
Wow. Gosh. And we were sitting here, we were going to wait that couple of billion years.
Yeah, we thought we
put it in the diary, but don't have to now. It's happening. Now, I know these gas surrounds have been previously discovered. We're talking, 70 odd years ago that they were discovered, but it's only because of a new piece of equipment they've been able to really analyse them today. Is that accurate?
It's one of the Keck telescopes are equipped with very, very fine auxiliary instrumentation, and one of them is the instrument that's been used to do this. It's basically it's got what's called an image slicer on it, and that does exactly what the name implies. It takes an image, slices it up, but then for each slice you can get a separate spectrum. We in Australia have similar technologies on certainly the Anglo-Australian telescope, but we don't slice the images. We break them up into pixels by using fiber optics. So it's a different technique, but it has basically the same outcome. But the thing about the image slicer is you can make them incredibly sensitive, and that's why they've been able to get the spectrum of oxygen out to these great distances from the galaxy at those incredibly faint levels. So yes, it's all about the technology that is now available on these marvelous telescopes.
Incredible. So beyond the extremities of the spiral arms of our galaxy and other galaxies even without those sorts of structures, there's a gas halo that stretches out that far again. Is that basically what they're saying?
That's correct, yeah. And perhaps the most startling outcome of the research that these scientists have done on this is that those gas halos, when you add them up for all galaxies, they probably make up, they believe, between 70 and 90% of the normal matter in the universe. Now, the normal matter is the stuff that's not dark matter or dark energy, and we know that we think of normal matter as being about 5% of the mass energy budget of the universe, and we usually think of that as being in stars. Stars are the glowing stuff, the stuff you can see. But actually, what they're saying is that much more of it is in these galaxy halos, 70 to 90%.
So does that change the ratio? Does that change the formula of what makes up the universe?
No, it doesn't. What it changes is the ratio within that 5%, which is normal matter. So what we're saying is that rather than half of it being stars and half of it being gas, most of it is gas. And that's a new aspect of this whole study.
Okay. Wow. That's intriguing. And they think this applies to just about every galaxy in the universe.
Yeah, that's right. Yeah.
That's incredible. Quite a discovery.
It is. And all credit to the team. And just to give a shout out to the instrument as well, the image slicer that we mentioned, it's called the Keck Cosmic Web Imager. And it's pretty dramatic stuff.
And it proves my theory, Fred, that the universe is built on baked beans.
Well, that's naturally what your mind goes to, really, isn't it?
Yes, it does. There's that much gas. Yeah. Yes. Fascinating story, and you can read more about that on the Conversation website. This is Space Nuts with Andrew Dunkley and Professor Fred Watson.
0G, and I feel fine.
Space Nuts.
Let's get into our final chat, Fred. This one is about disruption in the extremities of our solar system due to a passing star. So what happened and when?
Quite a long time ago.
I figured it might be.
Before you and I were born. It's a good question, actually. I'm not sure that they can pin down when this happened. But I should have another look at the paper because it's a paper in Nature magazine, which goes into details of this very nicely, and what they are doing, the scientists involved with this work, who are principally in Europe, if I remember, at the University of Leiden comes into my mind. Yes, the Leiden University is where this research has been done. So what have they done? They've looked at the trans-Neptunian objects, which we've talked about a lot because they are implicated in the idea of Planet Nine, and I'll get to that in a minute. But this group from Leiden University have done a huge number of computer simulations to see why these trans-Neptunian objects have such highly inclined orbits. When you think about the orbital plane of the solar system, the one that the planets lie in, that's pretty flat. I think Mercury is the one that sticks out most. But the trans-Neptunian objects are not like that. And I should mention that the main belt asteroids mostly sit within the plane of the planets as well. And that all comes about, of course, because of the way planets are formed from a rotating disk of material, the protoplanetary disk. But when you look really a long way out to the trans-Neptunian objects further away than Neptune, they're tipped over at all kinds of angles. In fact, some are vertical almost, and there's one or two that are so far angled that they're going the wrong way round. They're actually going in the wrong direction. And so the scientists at Leiden have questioned what it is that has caused this. And their simulations basically tell them that a star of about 0.8 solar masses, so 80% of the mass of our sun, flew past at quite a close distance, a distance of 110 astronomical units. Now, we know that an astronomical unit is the distance between the Earth and the Sun, 150 million kilometres. So it's 110 times that is about 16.5 billion kilometres, about nearly 4 times the distance between the Sun and Neptune. So that passage of a star, and they suggest billions of years ago, without pinning down exactly when it was, what they find is that tipped up many of these orbits and disturbed them so that we've got all these inclined orbits. But they also believe that this explains some of the peculiar orbits of moons of the outer planets, Jupiter, Saturn, Uranus, and Neptune. Some of those moons go the wrong way round. And it's always been suggested that they captured asteroids, basically captured trans-Neptunian objects that strayed into the inner solar system and got captured by these planets. And so what the Leiden scientists are saying is that it's maybe the same event when the star flew by the solar system not only disturbed all these outer asteroids to put their orbits at high inclined angles, but also flung some of them into the inner solar system where they were captured as moons. So it's a very, very neat story.
It makes sense, though, when you think about it.
Absolutely. It makes perfect sense. It's exactly the kind of gravitational disturbance that you think might do that. So, bless you.
Yes, that's Judy going off out there.
That's with the good old hay fever, I guess, still. Yeah. Now, I mentioned Planet 9 a minute ago, that great theory that I think had that around since 2016 or thereabouts, if I remember rightly. And that's saying that, yes, we've got very elongated orbits out in that outer solar system region, but some of them align in a way that's suspicious that there's another planet out there. So the paper that we're talking about now, which in Nature Astronomy is called The Trajectory of the Stellar Flyby That Shaped the Outer Solar System. It's a very nice title. That paper is very briefly includes a mention of Planet 9. And I'm going to read the paragraph that it's in. It says, eventually, high-inclination trans-Neptunian objects could be crucial when deciding between different hypotheses. Retrograde trans-Neptunian objects themselves, and that's ones that go backwards in their orbits, provide a challenge for the planet instability model. Adding a distant planet, in brackets Planet 9, appeared to solve the problem. This combined model can account for retrograde trans-Neptunian objects and with certain parameters. But it says, however, distant, highly inclined trans-Neptunian objects, if they exist, may provide a challenge also for the Planet 9 model. So what they're saying is Planet 9 actually helps in their theory. Maybe it's a combination of both, this passing star and a planet that we have not yet discovered in the depths in the solar system.
So to put it in super scientific technical speak, we had a solar system-sized bull in a china shop.
Yes, I think that sums it up very bovinely, if I can use that.
Bovinely.
Yes.
Well, the cow jumped over the moon, the bull...
Yeah, that's absolutely. In the china shop, yeah.
The bull did the rest. Yeah. Oh, it's a great story. And if it holds true, which it certainly, the mathematics works, could answer a lot of questions. And add a touch more weight to the potential for a Planet 9, which I like. I want it to be there. I do.
Yes.
Yes. If you'd like to follow up on that story, it's a good read, but it's super technical, so my brain went snap. Nature.com has that story. That brings us to the end, friend. Thank you so much for your presence yet again. It's always enlightening.
Better than end darkening, isn't it? Which is what we talk about.
Depending on where you are.
Yeah.
Yes.
No, great stuff, Andrew. Thanks for having me.
Always a pleasure. Fred Watson, astronomer at large, and thanks to Hugh in the studio. We got a question about Hugh the other day. I'll try and tackle that in a future episode. And from me, Andrew Dunkley, thanks for your company. Catch you on the very next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.